Today's focus is going to be on solar energy. Solar energy consists of both radiant and thermal, which we've talked about since the beginning of the school year. Okay, what is radiant, which we'll also talk about in another slide? That is light energy. And obviously we know the sun provides light energy. We also know that it provides thermal energy, which is our form of heat energy. Okay, so it provides us both with light and heat. Unlike previous units, solar energy is actually created not by the fission process, which we've learned during nuclear, but the fusion process. It is also a nuclear reaction, but with fusion, what you do is you fuse things together. So instead of with fission, where is one thing breaking up into two, so fission is division, fusion does the opposite. It takes two things to create one bigger thing. And this process releases a ton of energy, way more than actually a fission reaction does. Particularly with the sun, what the sun is doing is it's combining two hydrogen atoms, and it is creating a helium atom plus a ton, once again, ton of energy. All right. So radiant and thermal energy come from the sun, and what happens is, let's say 100% of that goes to the sun, right? And we've got the light energy, which is the movement of with these electromagnetic waves, and it's in transverse. Remember, it looks like the waves that we're used to. And then it also releases this heat energy, which is caused by the movement of objects. So the faster things are moving, the more heat energy it has. The slower things are moving, the less heat energy it has. And so what happens then is we have all of this incoming radiation. Obviously, it's not all of the sun, it's all coming from the sun, but all of the sun's radiation is not coming just towards the earth, okay? But how much of this solar radiation is absorbed? So out of all the radiation that hits the sun, how much is actually absorbed by the earth? Okay, so first off, you have to get rid of all these reflected. So things are reflected by the surface, they're reflected by the clouds, they're reflected by the atmosphere. But which ones are absorbed? Well, we've got 19% that are absorbed by the atmosphere and clouds, and we have 51% that are absorbed by the Earth's surface itself. Okay, so add those up and you get 70%. So 70% of the sun's solar radiation is absorbed by the Earth. So what causes differences in how much radiation we have? Because the sun actually gives off a consistent amount of energy. It's not like it amps up its stuff during the summer and then turns it down a little bit during the winter. It is all due to its tilt, okay? The Earth's tilt. Obviously, we're not perfectly vertical, so it's tilted a little bit. The rotation. Remember, the rotation is how the Earth spins on its own axis, and also the revolution, which is where it goes around the sun. Okay, all of these factors give you different amounts of sun radiation. So the rotation tells you whether you're day or night. The revolution tells you what season you're in. Other factors that can change your solar radiation is if you have cloud coverage, if you have some smog, the time of day, the season you are in, the latitude, and your daily weather. All right, so let's label the seasons in the boxes. Now and this is for the Northern Hemisphere seasons that we're talking about. Now I am not an earth science specialist. So this is how I figure this out. I find the sun, and then I find which image is the northern showing the sun the most often and the least often. So if I look at this guy, this little pie piece right here is a very small amount compared to this pie piece. This is a bigger pie piece, right? So which one would be summer, which one would be winter? You have summer would have to be this guy right here because it is exposed more to the sun. And then you have winter, which is the opposite and is exposed to the sun the least. So then working rotation, summer would be then go into fall. So this would be fall. Then it goes into winter. Winter would go into spring. And then spring would turn into summer. So that's how I get these. I don't know. If you have another way, great. All right. So this shows the average daily insolation per month. What an insolation is basically how much sun radiation covers a given area per hour. Okay, so looking at this, circle the area of the map with the highest amount of sunlight. I think that's actually on the next slide. Yep. And so looking at your key, which is down here, the reds are more sunlight, whereas the browns and yellows are least sunlight. So the highest area would be where our deserts are, which makes sense. All right, so we actually use the sun, and we've used the sun for its energy since the beginning of time. Some of the major uses that we use currently is that we use daylight. We use drying agricultural products. We actually use it for space heating, so heating up our places. We use it for water heating, and we actually use it to generate electrical power, both through concentrating solar power and through photovoltaics. Photovoltaics are what you think of as solar panels. All right, so what is daylighting? So daylighting is using the sun's sunlight to help light up your house so you don't need to turn to electricity. So how do you use those, or what type of resources can you use? You can use skylights. Tube lights are basically just circles. Instead of looking more of like this square type of thing, it's more of a circle that's in your ceiling, and then the sun goes down and then it releases the light into your hallways, bathrooms, whatever. Typically, you'll use tube lighting in smaller areas, and you'll use skylights in bigger areas. So like a bigger area would be your kitchen, tube lights would be your hallways. And then also large windows. Now it's key, obviously, to face these towards the sun, because that is the whole point of daylighting, is to collect the light energy released by the sun so that you don't need to use your own source of light. It also is used to dry agricultural products. One way that they used to do it a lot, and they still do it, is that they cut it down and they let the sun just dry it on the fields. Okay, that's a very low key way to do it. The other way that they've done it is they actually create this tube type of a thing. The sun radiation, this is also agriculture drying, the radiation creates a thermal energy, and here are your racks of your foods, your crops. And what happens is through heat movement, the heat then it goes up, right? And by that process, it heats up your crops and therefore dries them out at a faster rate. All right, they also use space heating through passive solar. So passive solar means you're just being passive. It's not active solar. Okay, so you're not using it actively to do something. It's just allowing whatever happens with the sun to do what it does. Okay, so passive solar designs use specific shapes, angles, and building materials to maximize or minimize the amount of solar energy, depending. Like if you're in a desert, you might want to minimize some of the solar energy because it's too hot, produces too much heat. Whereas if you're in the winter or in a snowier, less sunny area, you want to obviously maximize it. So this is one form of space heating. So or passive, so what they'll do is they'll use overhangs. Here's an overhang. So if you look at it, it obviously shields the sun from when it is at its most, which is during the summer, but during the winter when it's cooler, it allows that sun to enter into the building, and then therefore it can distribute throughout. Also, another thing that they'll use is concrete or stone. This happens a lot in the desert. So what happens is that concrete and stone can absorb energy, the sun's energy, at a slower rate. So what happens is it absorbs it, keeps absorbing it, it doesn't release it right away, unlike other materials. And so it absorbs it during the day. And then when it gets really cold at night in the desert, that will provide a source of heat. Okay, so it's slow to absorb, so it doesn't change its temperature a lot during the heat of the day, so it won't go extremely hot, these walls. But then what'll happen is during the night, it will actually release its heat slowly into a building, and therefore you can heat up your building without having to use actual heat. All right, so this is what's more of like kind of on that focus of the wall, but you've got a trome wall, which is made of absorbing material and painted black or whatever. And what happens is that it'll absorb that energy, and then that energy will be slowly released into where you are located. You also can have sun spaces. This is a lot more, it'll create a lot more heat. And what they do is it traps heat exactly like a greenhouse, and that heat will be slowly distributed to your, even through the floors, right? Slowly through your house. So you've got a trome wall, and then you have a sun space, which is like a greenhouse. All right, so these are just some designs, but really important, what you want to do is you want to make sure that it cools during the summer. So that's like the use of overhangs and using of like concrete and that type of materials, but then it heats during the winter. So you want the overhang to not cancel out all of the sun's energy, because you want it to be able to be accepted during the winter, but just not during the summer, things like that. All right, then there's active solar. And one way that you use active solar is you actually can heat water. I've seen this in Europe a lot, and what they do is they actually have their hot water heater basically on the outside of the building. And so the sun hits these pipes, or the cover, the glass cover, and then that glass cover heats up, and then it heats up the pipes that are inside of the panels, and then that's where your water is located, and then you get warm water. So here's an example of it right there. Another way that we actually use solar is to generate electricity. My guess is that you're pretty familiar with photovoltaics. Remember, photovoltaics are going to be your solar panels. Okay, and we have solar panels that are on a big scale and a small scale. So large scale would be where we are using it to generate a ton of electricity from multiple homes. Small scale would be like how you would generate it on your own house. Okay, or through construction signs and stuff like that on the sides of the road. Those would be small scale. Large scale is for utilities. Another way that we do it without using photovoltaics is we actually use the system using mirrors, and you've got a trough system and power tower system. Okay, so right here is your trough system. So basically they look like pig troughs, but they're mirrors. And what they'll do, we'll go into it more, but they they actually reflect the sun into more of a pinpoint area, creating a higher temperature in that area, which then can produce the energy needed to create steam and things like that. Or you could use power towers. For this one, all of these mirrors right here are focused towards a pinpoint area on this power tower. And basically what you're doing is you're concentrating a lot of solar energy into a specific point. So concentrating solar power, this one uses mirrors. So this is the trough system. So what if you look at this mirror, okay, and what they're going to do is it's going to reflect the sun to this point right here. Okay, it's going to reflect all of this light to this point right here. And what that's going to do is that is going to then heat up some salt or water in the system. This system then can go into a factory, which then will turn turbines, producing steam. It'll create the heat. The heat will then heat up water to create steam. The steam will generate, turn turbines. The turbines will generate electricity, things like that. Okay, so this is very similar to what you would do for a power plant, like a nuclear or coal or any of those types of things. Then you've got the power tower. What happens with the power tower is that you've got these heliostats. These are the heliostats. They are the mirrors, okay? And what they do is they focus all of their mirrors. They will move depending on where the sun's at, but they will focus all of their mirrors to a pinpoint on your power tower. So all of this energy is going to that power tower right here, a little pinpoint. And what happens is that this point right there will actually get, because of all the focus of the mirrors, will get between 550 degrees and 1500 degrees Celsius. Okay, so all of these mirrors, all of that energy will be reflected. It will go towards that pinpoint little area on the power tower. That power tower will become about 1500 degrees Celsius depending on the day. Okay, and so what happens is that you have these heliostats. So once again, those are the light reflecting mirrors that can move. You have them. What they do is they reflect this energy from the sun. They go to the receiver on the power tower. The power tower then becomes extremely hot. There's salt up here, and that salt will actually become almost molten. The molten salt will then go down towards through pipes towards a steam drum. The steam drum is where basically the water is. The water then will turn into steam. The steam will turn the turbines. The turbines will turn the generator will conduct electricity. So basically what you're doing is if you go back to like the nuclear unit, instead of using nuclear fission, to create heat, what you are doing is using the sun to create salt into a liquefied. You can also use water, but I'll just use salt. So you can turn salt into a liquefied or heated version, and then that heat will turn another set of water or a set of water into steam. The steam will turn turbines. The turbines will generate electricity. So it's basically where are you getting your source of heat. All right, just to let you know, the biggest one that we've got as far as power towers is in the Mojave Desert, which makes sense. It takes up a lot of space. As you can see down here, it's taking up a lot of space, and it also needs a lot of energy, a lot of source from the solar energy. So that makes sense of why it would be there. All right, so let's try to identify the pictures for these. The first one is going to be, you've got that agricultural drying. The next one is going to be your concentrated solar power. This one in particular is your trough system. Okay, so you've got these lovely mirrors and they're focusing their energy just to right here as opposed to a power tower. Then you've got your passive solar. Okay, and this one is using, for example, these overhangs so that you allow the sun during the winter to be in at almost all times, but not during the summer. The next one is active heating. So you've got this hot water being made on the top of somebody's roof. Then you have my personal favorite, which is the power tower, which is basically an electrical power plant that uses just solar energy. And then you have daylighting. So notice that this one is exposed to, by using of all windows, it is exposed to a lot of sun during the day. So you don't need to use artificial lighting. All right, hopefully you have a basic understanding of solar and have a great day.